Hey kids, Mr. Murray here, Mr. Murray's Mathland, and we are solving trig equations specifically by factoring with a greatest common factor, a GCF. So yes, this video is just about that, and there's so many different types of equations to solve here, but so we're just focusing on this type here. And for practice, we're going to solve over the intervals 0 to 2 pi and 0 degrees to 360. So we're going to answer in radians and degrees for practice with both. So hopefully you're looking at number one and you're already thinking of what you would do first. To solve any equation by factoring, you typically want to make it all equal to 0. So you bring everything over to one side, right? So I'm going to subtract 2 cosine of theta from each side and see if there's any like terms to combine it with. And there are right here. So my new equation is going to say 2 root 3 cosine of theta sine of theta plus 3 cosine of theta, when I combine those like terms, equal to 0. So equal to 0, now we're ready to factor. And, maybe it's trig, but it's the same principles as with polynomials and variables. What can I take out that each of these two terms has in common? And 2 root 3 and 3, no common factors for the coefficients, but they each have a cosine of theta. So you can factor out cosine of theta, make a set of parentheses, you're just undoing the distributive property, right? So when I take out that cosine of theta, you're going to have 2 root 3 sine of theta plus 3 when you take away that cosine. And then you set each factor equal to 0 and solve, right? That's the way it always worked, even with simple things going all the way back to Algebra 1. So we are now solving when does cosine of theta equal 0, and that's something we've solved before. And when we set this second factor equal to 0, right, it's a little bit weirder looking, but you're going to subtract 3 and divide by 2 root 3. So you're going to have negative 3 divided by 2 root 3, and that doesn't look super familiar at this point, but after you rationalize, hopefully it will. So we're going to multiply by root 3 over root 3 and see that that becomes negative 3 root 3 over 2 root 3 times root 3 is 6, and that reduces to negative root 3 over 2. And that is definitely something that is familiar looking. Okay, so now a little unit circle brush up if you're rusty with it. Here's something to, maybe one way to remember it. If you're a chart person, you think of 30, 45, 60, or maybe you're drawing your triangles right now, or your circle, or maybe you just know it. But in radians, that's pi over 6, pi over 4, pi over 3, right? Sine, cosine, tangent. What's the pattern? Over 2, over 2, over 2, over 2, over 2, over 2 for the sine and cosine of all three of these. Root 1, root 2, root 3, right, in that order, and count it back in reverse. Root 1, root 2, root 3 for the cosine. Sine divided by cosine gives you tangent, so look at those numerators. 1 divided by root 3 is root 3 over 3. Root 2 divided by root 2 is 1. Root 3 divided by 1 is root 3 for the 60-degree column there. And so maybe it's been a while, or who knows, but that's one way to quickly pull out those values. Now cosine of theta being 0, this first factor we're trying to solve, well, 0, that's always a quadrantal situation, so keep in mind that cosine is the x value on the unit circle. So when does the x value equal 0? 2 locations, right? When you're 0, 1, or 0, negative 1 on the circle, and that's at the angles of 90 degrees or pi over 2, and down here 270 or 3 pi over 2. So first we can say theta is equal to pi over 2 or 3 pi over 2. And now when does sine equal negative root 3 over 2? So sine being root 3 over 2 always happens at pi over 3 or 60-degree reference angle. But where is sine negative? So don't forget your All students take calculus, or all Santa Claus, however you want to remember it. But sine is negative in quadrants 3 and 4. So quadrant 3, quadrant 4. So the quadrant 3 angle with a pi over 3 reference angle is 4 pi over 3, right? One more than the denominator, or pi plus pi over 3 gives you 4 pi over 3. Quadrant 4, double the denominator minus 1, or 2 pi minus pi over 3 gives you 5 pi over 3. And there's our radian solutions. Degrees, you can either convert those or just know them. Maybe they're so familiar by now. That's 90 degrees, 270 degrees. 4 pi over 3, like we said, is 180 plus 60 degrees, 240. Or convert by doing 4/3 times 180. 5 pi over 3 is 5/3 times 180, or 360 minus that reference angle 60, 300 degrees. Okay, so there's our answers in radians and degrees to number 1. All right, so I'm going to do a little copy of this chart in case I need it for the next couple problems, in case I want to refer to it. Okay, number 2 here, number 2. So we are solving this. Now just be careful. I've seen very good students make this mistake in the past when you have a common trig function on both sides and they just divide by tangent of theta to get rid of this and pretend it's not even there. But when you do that, you're losing some potential solutions. So you try to never divide by variable expressions here, if you can help it. So what do you do instead? You bring it all to one side and factor. Right? Same thing you did with, x squared equals x back in the day. You bring it all to one side. You don't divide by x. So subtract 2 tangent of theta is equal to 0. And now we can factor out a common factor of tangent of theta. So when I take out that common factor of tangent of theta, make your parentheses, you'll have secant of theta minus 2 on the inside. Set each factor equal to 0. Hopefully you're rolling now. Tangent of theta equals 0. That's something we've definitely dealt with. And setting this factor equal to 0 will yield secant of theta equals positive 2 after you add 2 to both sides. And if that's not familiar as is, remember you can always change it into its reciprocal function. Reciprocal of secant is cosine. And so the reciprocal of 2 is 1/2. So you're really saying, when does cosine equal positive 1/2? And so we'll bring that chart back just to help us see this. For the first equation, tangent of theta equals 0. Again, you are talking about a quadrantal situation. And remember, tangent is y over x, or sine over cosine. And when you're talking about y over x, or sine over cosine, or any fraction equals 0, in order for a fraction to be equal to 0, you're really talking about the numerator equals 0. So you're really just saying, where is sine 0? And so that's saying, where's the y coordinate 0? And that would be right here and right here on the unit circle, right at the points 1, 0 and negative 1, 0. And those angles are at 0 radians and pi radians. And notice I said 0 and not 2 pi for this location because of our interval is inclusive on 0 with the bracket and exclusive of 2 pi using the parenthesis there. So occasionally they'll both have brackets or both have parentheses, and then I would include both or not include either, but just pay attention to those when you're on the cusps of the intervals. And now for cosine being positive 1/2, cosine being 1/2, that's again a reference angle of pi over 3 or 60 degrees. Where is cosine positive? That would be in quadrant 1 where everything's positive, and in quadrant 4. So quadrant 1, quadrant 4. Quadrant 1 is pi over 3. Quadrant 4 is 5 pi over 3, double the denominator minus 1, or 2 pi minus that pi over 3. There's our radian solutions, and in degrees, that's 0 degrees, 180 degrees, 60 degrees, and again, 300 degrees. As we saw in problem 1 also. Okay, and one more just to see a little variety here. Oh, and by the way, it should be noted in this problem that none of these solutions are extraneous, although you should be thinking of checking especially when you have a problem that contains functions like tangent and secant, which are undefined at certain values. You know, there are domain restrictions in the original equation, but if you do go back and plug these into the original, you will get true statements. Nothing will be undefined. So I just didn't want you to think I assumed that is the case, but that is the case for that problem. And number 3, we're going to solve this. So very similar. We're going to bring everything to one side, right? So I'm going to subtract that sine squared, that quadratic term. And we'll have sine of theta cosine of theta minus sine squared. I can't combine those. And this is just like any other polynomial factoring. I'm going to factor out. This has sine of theta and this has sine squared. So I can take out 1 sine of theta. And we'll have cosine of theta minus sine of theta on the inside. Set your factors equal to 0. You're solving when does sine equal 0. And this equation, when does cosine equal sine? When you set that factor equal to 0, you end up trying to solve that, which, you know, that's a little weird. So this first one, we actually just solved this a minute ago when we said when does tangent equal 0. That's right here, right? When sine is 0, when the y-coordinate's 0, that's at 0 and at pi. So let's just get that one right out of the way. Again, 2 pi is not included in our interval, so we're answering with 0. Cosine of theta equals sine of theta. So a couple ways to approach this that you can just think about it if you like. You're talking about, is there an angle where sine and cosine have the same value? And yeah, there's one time when sine and cosine have the same ratio, and that's when you're talking about pi over 4. So now think about the quadrants here. In quadrant 1, both are positive. So that's where they have the same value in quadrant 1. In quadrant 2, sine is positive, but cosine is negative, so they don't have the same value there. They'll have opposite values. In quadrant 3, sine and cosine are both negative, root 2 over 2, so they have the same value. They're both negative. And that's what we're trying to determine. When does sine and cosine equal each other? And in quadrant 4, they have opposite values again. Cosine is positive, sine is negative. Although sometimes, like if this had been a plus, then this would be a negative, or one of these would be negative, and that's when you're trying to find when they're opposite. These are when they're the same, 1 and 3. So quadrant 1 and 3, reference angle of pi over 4. Quadrant 1, that's pi over 4. And quadrant 3, that's pi plus pi over 4, or just one more than the denominator as that little pattern plays out, 5 pi over 4. And so there's that. If the whole, thinking about it doesn't sit well with you, like you feel like there should be a more algebraic way to arrive at those two pi over 4 solutions, one thing you could do is this. It doesn't normally jump out at you, but it's definitely an option. You could think of dividing both sides by sine or by cosine to make one side of the equation be 1. And if I do this, I get 1 on the left side, and sine divided by cosine could be thought of as tangent. And then you're solving for, tangent equals 1, positive 1 in quadrant 1, and quadrant 3 where tangent's positive. And so at pi over 4 and 5 pi over 4. So there you go. And I said earlier in this same video that you try to not divide by variable expressions, but it's okay in this one because it doesn't disappear. I'm just using it over here to make a different expression. So it's not like we just took it away and we forgot about any potential solutions it contained. So there's our radian solutions, and in degrees, that would be 0 degrees, 180, pi over 4 is 45, and 5/4 times 180, or just 180 plus 45 will give you 225 in quadrant 3 there. So there we go. A few quirks and a good little unit circle review, as well as a little factoring practice. So hang in there, keep working hard. Let me know if you got any question, kids.